Hello dear students, you are welcome to the fourth session of a first unit. In the third session you have learned what is the meaning of sensitivity, repeatability, threshold, and if you want I can repeat what is the sensitivity. Sensitivity, it is defined as the ratio of output response to a specified change in the input, or sensitivity refers to the ability of measuring device to detect small difference in a quantity being measured. That is, sensitivity equal to output response divided by change in the input. Next term we have discussed is repeatability. It is defined as the ability of a measuring system to reproduce output readings when the same measured value is applied to it consecutively under the same conditions and in the same direction. And third term we have discussed is threshold. If the instrument input is very gradually increased from 0, there will be some minimum value below which no output change can be observed or detected. This minimum value defines the threshold of the instrument. So in this session we will discuss hysteresis. It is also one of the important terms in the mechanical measurement while selecting the instrument for various measuring purposes. It is the difference between the indication of a measuring instrument which the same value the measure and quantity is reached by increasing or by decreasing that quantity. So what do you mean by hysteresis then? For example, if you take any ferrous metal and if you magnetize it, ಏನಾಗುತ್ತೆ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ಪ್ರೋಸೆಸ್ ಅಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ 0 ಇಂದ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂ. when you want to demagnetize the magnetism ಕಡಿಮೆ ಆಗ್ತಾ ಬಂದು 0 ಗೆ ಬರುತ್ತೆ. But in actual practice the curve, it is not a linear curve. So what does it mean? So when you magnetize a ferrous metal from 0 to particular value reaches, while demagnetizing ಮಾಡಬೇಕಾದ್ರೆ the ferrous metal will not leave all the magnetism. Some amount of magnetism will remain in that. So the curve will not be perfect linear. So if you see the graph in the slide, there is output value to the input value or input value to the output value from 0 to hysteresis, that is upscale and downscale. So normally under the standard condition that curve should be linear, but here it is not so. That means the hysteresis, some amount of the magnetism ಅಲ್ಲಿ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಅದನ್ನು ಏನು ಹೇಳ್ತಾರೆ, hysteresis ಅಂತ ಹೇಳ್ತಾರೆ. The hysteresis arises because of mechanical friction, magnetic effects, elastic deformation or thermal effect. What is the mechanical friction? So you know what is the mechanical friction, because any instrument, if you take any instrument, there are a number of moving or mechanical parts which moves one above the other. So it will offer a hysteresis property. Second, magnetic effect. This already I have explained. Next, the elastic deformation or thermal effect. What do you mean elastic deformation? When you apply a load on some metal or a element, it undergoes a deformation. When you release the load, what happens? It will come to its original position. That is the perfect elastic. Suppose it will not come to its original position, then it is called hysteresis in this case. Hysteresis also result in the pointer not return completely to 0 when the load is removed. So it is a very one of the important term. So while selecting the instrument and also while starting the instrument, you have to set the instrument to the 0 or pointer to the 0. Otherwise we will end up with some error. So that means That is because of in some of the instrument the pointer will not come to its original position. If you are, for example, if you use the voltmeter or galvanometer, there you have a pointer on the scale, so it has to have some range 0 to some maximum or larger value. So while doing the experiment, it has to show the volt in voltmeter. So after switching off the current, the pointer should come to 0. Suppose if stops somewhere in between, then the instrument will not give the correct reading. That means the pointer should come to the 0 when the load is removed. A system free from hysteresis will produce same output reading. So when any device is used to measure any parameter, first for increasing values of the measurand and then for decreasing value of the measurand, the two output readings obtained usually differ from each other, which is known as a hysteresis. Hysteresis is due to certain amount of internal or external friction of the sensing element. The hysteresis is mostly observed in mechanical devices due to backlash of gears, friction, elasticity of materials. Errors due to the hysteresis are known as hysteresis errors. It can be reduced by proper design and selection of the mechanical components with suitable heat treatment to the materials. What do you mean heat treatment? Suppose if you use the material without heat treatment, then that instrument, suppose if it is exposed to some temperature or hot condition, then that material which is used in the instrument will either contract or expand. Then ultimate whatever the reading you are getting is error. Next is the calibration. One important procedure followed in the mechanical measurement is the calibration. So calibration is the process of establishing the reliability of the measuring instrument. For every measuring instrument must be reliable. That is, the result obtained must be closest to the actual values. So what are the calibration? See, if you are using an instrument for a longer time or a prolonged, after the prolonged use of an instrument, it may lose its certain properties. Then that instrument will not give the correct reading. So every time or often you have to calibrate. What is the calibration? Calibration is nothing but comparing your instrument with the standard instrument. I will give you a small example. When you go to the grocery shop, they are having a weighing machine. So if you ask them a 1 kg of a rice, they will measure the rice using their weighing machine. But after prolonged use, the weighing machine may not give the exact 1 kg of a rice. So what they have to do is, they have to calibrate their weighing machine with the standard one. How? The simple example is, if you take a 1 kg of stone, ಮೊದಲಿನ ಕಾಲದಲ್ಲಿ ಕಲ್ಲುಗಳನ್ನು ಯೂಸ್ ಮಾಡ್ತಿದ್ರು. 1 kg ಕಲ್ಲು, 2 kg ಕಲ್ಲು, 3 kg, 5 kg ಆ ಥರ ಕಲ್ಲುಗಳನ್ನು ಯೂಸ್ ಮಾಡ್ತಿದ್ರು. That is the standard one. So if you take a standard 1 kg stone and if you keep it on the that weighing machine, then weighing machine has to show 1 kg. Suppose if it shows a 950 grams, then the error is 50 grams. That means your weighing machine should be repaired, or you have to give it for repairing purpose or repair ಮಾಡಲಿಕ್ಕೆ ಕೊಡಬೇಕಾಗುತ್ತೆ. So normally this calibration is done by meteorological department. So it's a government department. Often they will visit the shops and they will calibrate their instrument and they will give. Otherwise, what will happen is, if you go to the grocery shop or any other shop, you may not get the exact weight. Another example is, if you go to any fuel petrol bunk, So there they are giving the petrol in the units of liters. Suppose if you have doubt, then you can check the measurement. How? You can visit the any metal shop. They will give the measuring instrument, and you go to the petrol bunk, and ask them to give the 1 liter of petrol, and you put it on that instrument. If it shows the exact 1 liter, then the petrol bunk 1 liter and whatever you are having the instrument, if both shows same, then the whatever the petrol is given by the petrol bunk, their measurement is correct. Another example I can quote is UTM, Universal Testing Machine, which you can see in your mechanical MTQC lab. So there you are going to test various tests like compressive test, tensile test, shear test, etc., etc. But you may not be knowing whether that machine is giving the correct value or not. So once in a year or once in a month or once in 2 years, you have to calibrate at UTM with the standard one. You may be knowing one instrument is called probing ring. So you have to take the probing ring and you have to keep the between the jaws. Then you apply the compressive load. When you put the suppose if you put 1 ton of load, then probing ring has to show the 1 ton. Then you can tell the UTM which you are using is a perfect one. Otherwise, you have to set it right or you have to repair. So that means all the measuring instrument should be calibrated once in a year or as specified by the government. Next, the calibration procedures involves comparison of a particular instrument with the primary standard or a secondary standard or a known input source. So first, what is the primary standard? So from the previous in the previous session, you might have studied different standards: primary standard, secondary standard, tertiary standard, and working standard. What is the primary standard? The primary standard is the most accurate one. The secondary standard is the close copy of the primary standard. Tertiary standard is the close copy of the secondary standard, and the working standard is the close copy of the tertiary standard. For example, the primary standard, suppose if you want to calibrate your any instrument, you cannot compare it with the primary standard because primary standard is kept in very few places. So you have to take either a secondary standard or a working standard to calibrate your instrument. Known input sources. As I told in the previous slide, the simple measuring or calibration procedure is take 1 kg of weight and keep it on your weighing machine. If it shows a 1 kg, then your weighing balance or weighing machine is perfectly alright. Suppose it shows a 950 grams, then 50 grams is the error. Then you have to repair the weighing balance. That is nothing but a known input source. Similarly, if you want to calibrate the voltmeter or a galvanometer, then it's a simple thing. If you take a voltmeter, supply some known input, then voltmeter has to show the same input. That means input value and output value should be equal. Otherwise, your voltmeter is requires some repair. So this is the process of calibration. So dear students, this calibration is very, very important in mechanical measurement or metrology, because the purpose of the measurement is to quantify the things, and finally in the design stage or later stage, production stage, you have to check. So if your whatever the instrument you are using is not up to the mark or not up to the standard, then whatever the reading you are getting is the error. And finally in the production or wherever you are producing some item will be defective. So it is very important thing is to calibrate all the instrument as and when required. Another example, a flow meter may be calibrated by comparing it with a standard flow measurement devices. Another flow meter of known accuracy or by direct calibration with a primary measurement. The third method may be easily achieved by weighing a quantity of a liquid in a tank and recording the time taken the liquid to flow through a meter. Calibration procedure. All instruments must be checked for accuracy at regular intervals as specified by the manufacturer. So this is very important. All the instruments. Suppose in your lab, if you have purchased a vernier caliper or a micrometer, then the manufacturer will suggest when you have to calibrate your instrument. At that particular point or at that particular day, you have to inspect it, or you have to check your instrument with a standard. Otherwise, your instrument will not give the error. For example, if you have forgotten or if you are intentionally you are not doing the calibration procedure, then in future stages or future the instrument which will give the error, then that error will reflect on the production, and that with that production you will get the defective items. Hence, all instruments must be checked for accuracy at regular intervals as specified by the manufacturer. That means all the instrument is not required to calibrate once in a week or once in a month. But depending upon the accuracy and precision required, the calibration procedure has to adopt. For example, your scale is not needed to calibrate because it is a very cheaper one. If your scale is defected, then you will throw it out and you can purchase one more scale. That means calibration is not required for all the measuring device. So the instrument which is very costly and you cannot purchase every time, then that instrument should be calibrated. Second, the calibration of the instrument is carried out in laboratories by standards. So that means, as I told in the previous session, all the measurement process or procedures should be adopted or followed in a controlled atmosphere. Otherwise, whatever the measurement they will do, it will be affected by an environmental condition. For example, temperature, humidity, which will greatly affect on the measuring process. That means, although calibration procedure is very important and should be very accurate and precise one. So you are not supposed to conduct any calibration procedure outside the laboratories. So you have to conduct inside the laboratories as per the standards set up by the international standards. These substandards are periodically checked against some standard held permanently in the National Physical Laboratory. That means calibration is nothing but checking or comparing your instrument with some standard one. So in the laboratory you have a substandard. So you are calibrating or comparing the substandard with your instrument. So that substandard also, after prolonged use, it may lose its accuracy and precision. That means your substandard also should be calibrated or compared with some other standards. That is the meaning of these substandards are periodically checked against some standard held permanently in a National Physical Laboratory. So dear students, so far you have studied or learned or you are aware of what is the hysteresis and what is the calibration. So after this we have some of the multiple choice question to check whether you have know the concept or not. First one, the process of determining an error in an instrument is called. The process of determining an error in an instrument is called what? Options are given: calibration, hysteresis, repeatability, range. How? Suppose if you want to check whether your instrument is giving a right or wrong result, how you can check? It's nothing but a calibration, So you are comparing your instrument with the standard. If the reading of both are same, then you can tell your instrument is correct. It's not giving error. Suppose if the output is deviating from the standard one, then your instrument is giving some error. That process is called calibration, is it not? So options are given: calibration, hysteresis, repeatability, range. The answer is option 1, calibration. The question number 2. Which of the following adjustment is usually adjusted first in an instrument requiring a calibration? For example, in your science laboratory, you might have used vernier caliper. So what is the first step while doing the measurement? First you have to set the instrument to the 0. That means you have to bring both the jaws, movable jaw and fixed jaw together, and you have to see the reading. The reading should show 0. That means 0 setting. Suppose while movable jaw and fixed jaw, if it is not coinciding and it giving some reading, then you can say the instrument is not perfect, or the whatever reading you are getting, you have to add to the or subtract with the result. So options given: hysteresis, span, range, 0. The option is 0. The pointer in an instrument is not returning completely to 0 when the load is removed is the effect of. The pointer in an instrument not returning completely to 0 when the load is removed is the effect of. For example, if you are measuring voltage with a voltmeter, you are giving an input, the scale or pointer which shows some reading on the dial gauge. After disconnecting, or if you take out the load, then the pointer has to come to the 0. Otherwise, what is this effect? The options given: hysteresis, range, sensitivity, precision. The answer is 1, hysteresis. Question number 4. The process of establishing the reliability of a measuring instrument is called. The process of establishing the reliability of a measuring instrument is called what? What is reliability? ನಂಬಿಕೆ. ಯಾವುದೇ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡುವಾಗ ಅದು ಕರೆಕ್ಟ್ ರೀಡಿಂಗ್ ಕೊಡ್ತದೆ ಮತ್ತೆ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಕೊಡ್ತದೆ ಎಂಬ ಭರವಸೆ ಇರಬೇಕು. ಸಪೋಸ್ ಮೆಜರಿಂಗ್ ಮಾಡಬೇಕಾದ್ರೆ ಮಧ್ಯದಲ್ಲಿ ನಿಮ್ಮ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ರೀಡಿಂಗ್ ಅನ್ನು ಕೊಡದೇ ಇದ್ರೆ ಅಥವಾ ಎರರ್ ಕೊಟ್ಟರೆ ದಟ್ ಇಸ್ ನಾಟ್ ರಿಲಯಬಲ್. ಸೊ ಹೌ ವಿ ಕ್ಯಾನ್ ಅವಾಯ್ಡ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್? ಇಟ್ ಈಸ್ ನಾಟ್ ಲಿಮಿಟ್ ಫ್ರೀಕ್ವೆಂಟ್ ಕ್ಯಾಲಿಬ್ರೇಷನ್ ಮಾಡ್ತಾ ಇರಬೇಕು. ಸೊ ನಿಮ್ಮ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಅನ್ನು ಯಾವಾಗ ಕ್ಯಾಲಿಬ್ರೇಷನ್ ಮಾಡಬೇಕಂತ ಹೇಳಿದರೆ ಅದೇ ಟೈಮ್ ಒಳಗೆ ಅದನ್ನು ಕ್ಯಾಲಿಬ್ರೇಷನ್ ಮಾಡಿದರೆ ನಿಮ್ಮ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಈಸ್ ಮೋರ್ ರಿಲಯಬಲ್. ದಟ್ ಮೀನ್ಸ್ ಆಪ್ಷನ್ಸ್ ಗಿವನ್: ಎರರ್, ಕ್ಯಾಲಿಬ್ರೇಷನ್, ಥ್ರೆಶೋಲ್ಡ್, ರೇಂಜ್. ಆಪ್ಷನ್ 2, calibration is the answer. Question number 5. The difference between the indications of a measuring instrument when the same value of the measurement quantity is reached by increasing or decreasing that quantity is called what? ಅಂದರೆ ಯಾವುದೇ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಗೆ ಇನ್ಪುಟ್ ಕೊಡ್ತೀರಿ ಅದು ಔಟ್ಪುಟ್ ಕೊಡ್ತದೆ, ಆಮೇಲೆ ಔಟ್ಪುಟ್ ರಿಲೀಸ್ ಮಾಡುವಾಗ ವಾಪಸ್ ಅದು 0ಗೆ ಬರಬೇಕು. Another example I quoted is magnetism. When you magnetize a ferrous metal, the magnetism reaches its the maximum value. When you want to demagnetize, it has to come to the original position and the 0th position. But it will not so. So when you magnetize, it will reach the maximum value. While demagnetize, it will not come to the 0 position. That some of the magnetism will be retained by the material. That is called hysteresis. So options given: random error, hysteresis, threshold, all of the above. The option is hysteresis. We have referred the books, and also you can refer the Mechanical Engineering Measurement by Thomas Beckwith and Louis Beck. Reference books: Mechanical Engineering Measurement by A.K. Sawhney, Metrology and Measurement by Anand K. Bevur, Principle of Engineering Metrology by Reja Rajendra,